Okay, so now that we've spent several days talking about chi-squared, let's go ahead and talk about some limitations on it, some issues that you could potentially have. Now, I'll go ahead and say at the start that this right here, I'm not going to quiz you on it, I'm not going to test you on it. Really, the only way this is going to affect you is if you use chi-squared on your IA and you come across these particular items. There are two that we want to take a look at. One, any of the expected frequencies are less than 5, or 2, the degrees of freedom is 1. So if you're dealing with a 2x2 table, you're probably already going to want to go ahead and be using the Yates Continuity test, which I'm going to show you in just a second. Okay, so these situations may arise in internal assessment tasks, but you will not be required to deal with them on examination. So it's not going to show up on the paper exam, nothing like that. But if you do go ahead and use the strategy on your IA, it's not a bad idea to go ahead and bring up, maybe even if you don't need it, just to kind of further demonstrate your knowledge, okay, about that particular topic. So the first one, let's say that your expected frequencies, any of those cell values are less than 5. Okay. The chi-square test may be unreliable if any of the expected frequency values are less than 5. Consider the contingency table alongside. Now, last year I went through this, and I went ahead and had everybody do the problems by hand, and I'm really thinking this year it's not really necessary unless people just want to do that, because I'm really thinking this more is just like an addition to the lesson we were just looking at. So let's take this table, and let's go ahead and run through. I got my notes right here. There we go, so I don't have to keep going back and forth. Let's go ahead and take this. Looks like we have categories of watching TV, rarely, sometimes, often, and very often, and we're going to break that up by gender, male and female. So this is a 2 by what? Okay, so let's go ahead and plug this in. 2, 10, 4. Okay, so 2 by 4. Let's go ahead and plug in these values here. So 12, 15, what do we got here? 10, 8, and then we got 22, 21, 11, and 1. Okay. So now I would go ahead and store this under some name or some letter. Okay, just like we've done before. And now walk me through the keystrokes again. I know I hit menu. Statistics. Stat tests. Chi-squared, we want the two-way. There we go. And then we'll type in the name of the matrix that has my observed values. And here we go. Okay, so on the paper, it does say, our chi-squared value is 8.52. So that matches up. But let's go ahead and take a look. What I'm interested in is the expected frequency values. So I'm going to hit variable, okay, EXP matrix. Okay. Now, this is a 2 by 4. Now, this problem is going to occur if you have any values that are what? Less than 5. And you'll notice I have 2 cells that are less than 5. Okay, we got a 4.05 and a 4.95. We just want to make sure that the data is distributed. Yes, ma'am. Oh, what did I do to get this? The expected matrix? Okay, what I did was, once you have all this information here for chi-squared, then you go to variable, this time without hitting the control button, and then you want EXP matrix, the expected value matrix. There you go. Okay, now there is one rule that kind of goes with this. If the number of cells in your matrix, okay, less than 5 is less than 20% of the total. The number of cells having less than 5 is less than 20% of all your cells, you should be fine. Okay, but this isn't. In fact, we have 2 out of 8, so that's what? 25%. So this one, we can't go with that rule. So it is still possible for your results to be reliable and okay if less than 20% of your cells is less than 5. If more than 20% is less than 5, well, then we're going to have to go ahead and do something about this. And let's see what we do. Okay, now we can improve the reliability of this test by combining rows or columns so that there are no cells with expected frequency less than 5. In this case, we combined the often and the very often columns to produce this. And it really makes, a lot of sense, because if you're looking at this, how would you really distinguish often from very often? I mean, the person themselves might have some kind of idea, but anybody reading it without any kind of explanation would just think, well, those two are very much related, right? So what you're going to do in order to fix this problem, if you have expected frequency value cells less than 5, cells that are related, you'll just go ahead and combine those. Okay, so the 9.45 plus the 4.05 resulted in the 13.5, and now 11.55 plus the 4.95 gave me the 16.5. Okay, so by combining these, if I were to go ahead and put in the values now, and I'm not going to worry about plugging it in again, okay, so now my chi-squared calculated value is 4.18. Remember, what was it prior to this? Yeah, 8 point something. That was a huge difference, right? Okay. Now we conclude that the variables are independent. So this is different than what we had before. Because before, we had the unreliable idea that, yeah, there's some kind of relationship going on here, that maybe males or females watch more or less TV at certain times. But it turns out that that was not correct. Okay, and one of the indicators is if your expected frequency values happen to be less than 5. Okay, but you're okay to have a few cells that are less than 5 if the total percentage doesn't go over what? If it doesn't go over 20%. Okay, if it's more than 20%, then you'll probably want to go back and look at your observed data. If it's less than 20, you should be fine. Okay. Yes.
Should we expect to see something small?
No, 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 no. I will not quiz you on this. It's not going to show up on any test. In fact, like I said, the only way this is going to possibly come back for you to see it later in the year is if when you're writing your IA and you perform a chi-squared test, you see some values in your expected frequency table less than 5.
Okay, so like on our quiz, like we will never see them to be less than 5, really?
No, everything, all the problems I have, I believe should work out just fine.
Okay.
Yeah. In fact, I don't believe I have any there less than 5. I have to go back and look, but I'm pretty sure I don't. Yes.
So I'm just trying to wrap my head around how I use this limitation factor for my topic. So like let's say topic I'm talking about how heights and how if there's a connection between heights and the number of goals of soccer players.
Okay, so heights and goals.
And so I'm trying to figure out. So let's say there's one player over 6 foot, but then there's like one player that's 5'8", one player that's 5'7". Could I like range my heights like less than 5'5", more than 5'6"?
It probably would be more beneficial to you to go ahead and put your data into class intervals, and definitely make them of equal width. But yeah, I think that would probably be a really good idea. Okay, good. So questions? No, not too bad. Okay. So let's see here. So we have, a couple of these, some examples. Like, take a look at number 2 real fast. The following table is a result of a major investigation considering the 2 factors of intelligence level and cigarette smoking. Well, you'll notice, take a look at your columns here. The intelligence level goes from low to average to high to very high. Again, you've got 2 columns that are very closely related. Yeah, how would you tell the difference between what you consider high and very high? So if we were to go ahead and test this at 1%, in fact, do you want to go ahead and run through the problem?
Sure.
Okay, so let's see here. First off, let's run the problem as is. We're going to test it at a 1% level. So would someone look in your notes real fast? We need to figure out the degrees of freedom with the 1% because we need my critical value. Okay, so the degrees of freedom, he says, is 8. Would you guys agree? I would say 6. Because right now, see, we have 3 rows.
Yeah, you're right.
So that would be 2 times the 3. So we're looking at 6. Equals 6. So with a degree of freedom of 6 at a 1% level, this would be what? 16.81. Okay. So let's go ahead and run through very quickly, and let's see what we have here. If I go ahead and run with the data as is. All right, so just give me 1 second, maybe another one, to go ahead and plug this in. Okay, so we have a 3x4. Okay, so this is a 3x4. Okay, so I've got 279, 386. What's that? 96 and then 2. 96, 2. Okay, 123, 201, 58, 5. Okay, then 100, 147, 64, and 2. Okay. Yes. Oh, well, I'm going to show you the difference. Show you that how if you go through it originally and then change it, it can give you different results. Okay. So now let me go ahead and. I mean, you could go ahead. I mean, it really depends on how much time you want to spend on it in your IA. Instead of showing the original data, you could just bring this up and kind of explain to the reader, what it is, why you're doing it this way, because there's a formula that's also different if there's another circumstance. But, as far as the columns go, if the only issue is you have values less than 5, then maybe I would go ahead and correct it prior to even putting it in the paper so that you don't have to deal with this at all. Okay. So the only time I probably even say you may want to go ahead and put this in your IA is if you have degrees of freedom of what? 1. So if you have a 2x2 contingency table, you're probably going to want to use the revised formula that I'm going to show you, which is Yates in just a second. But I mean, you could. I haven't seen anybody ever put in the original data and then go back and say, okay, because I had expected values less than 5, I'm going to redo it after combining these. I mean, I think it would probably lend more towards validity, and you're really thinking about your data, but I've never seen anybody do it. I don't know. Are you considering that? Don't know. Okay. Alrighty. Well, let's see what my chi-squared value is. So menu, stats. Oh, I want stat tests. 2A, X. Okay. All right. So it looks like my chi-squared is 16.92. Okay. 16.92. Now remember, we were just told that our critical value was what? 16.81. So chi-squared calculated was about 16.92. Now my calculated was greater than 16.81. Remember, what are we wanting? There you go. So according to what we've been talking about all week, I would go ahead and say, well, there's got to be some kind of relationship between intelligence level and how heavy of a smoker you are. Okay. But now, like Michelle was just asking, we have these two columns here that are very closely related. Let's go ahead and combine those. Okay. Let's see what happens to my results when I go ahead and do that. Okay. So I'm going to come back over here. So now, because I'm combining two of the columns, my dimensions have changed. It's now a what? 3x3. Okay. So I'm going to choose this guy right here. And let's see. So that would be 279, 386. And I'm going to add the values for the last two columns in each row. So this one is now 98. Then I'm going to go ahead and say 123, 201, and that would be 63. Okay. And then 100, 147, and then the last one is now 66 because I added the final two rows. Okay. So let's see here. I'm going to hit Control Store. Now I've already got one in there stored as X, so I'll go ahead and just choose another letter. Let's say Y. Okay. Okay. Oh, okay. Sounds good. All right. menu, statistics, stat tests, la 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 la, two-way, and this time I'm going to go with Y, and why not? Okay, so see, it did make quite a bit of difference in my chi-squared value. So now I have 13.18. There you go. Now the results are saying there is no association between intelligence level and how heavy of a smoker you are. Okay. So see, that can affect the outcome, maybe beneficially, maybe not. In this case, there is no relationship. And, even if, say, there was, I'd be kind of hard-pressed to go ahead and find a relationship between, it is high intelligence, right? High intelligence and smoking, especially with all the ads out there nowadays, truth.com and things. Okay. Not that if you smoke, you're not smart. I'm not saying that. I'm going to stop talking now. Okay, so there we go. All right. So how are we doing? Yes, Eli.
So the only problem that actually exists either had a 2 by 2 table, or we had one of our values of our expected to be less than 5.
Less than 5, yes. And it was like Michelle was asking, even if, because you're going to go over your data before you go ahead and start to put it into your paper. So if you come across this, just the problem where you got expected value cells which are less than 5, maybe as far as the paper is concerned, the reader never sees that. You just go ahead and combine some of your columns to avoid that mistake altogether. So if you want to put it in there, maybe you can. In fact, let's see what the expected values would be for this new test. So I'm going to hit variables, expected. And now after combining those columns, I don't have any values less than 5. Okay. Yes, sir.
So I'm trying to figure out how to do that. But I'm scared that I'm having less than 3.
I don't know about percentages. I would have to ask our resident statistician about that. But if you're trying to create a contingency table, what are all the colors in the bag of M&Ms? We've got red, yellow, blue, green.
Orange.
Is green still there? I don't know. They change that occasionally. But, I mean, you could create a large enough table because you're talking about looking at different bags, right? So maybe the rows are the different bags and your columns are the different colors.
Yeah.
So in that case, I mean, you just have the actual number and you don't have to worry about percents. But you could go ahead and incorporate that in as I think what they're referring to as a basic math principle. What's that?
My fear is that the actual number was less than 5.
Oh, well, I would say let's set up the table. Have you already started looking at bags of M&Ms? Okay, let's do that and work up your expected frequency values. And if any are not less than 5, we're good to go. If they are less than 5, we'll figure out a way to deal with that. Okay. Just get a bigger bag. There you go. Oh yeah, I mean, it's Halloween's coming up soon. You're gonna be able to buy any kind of candy you want. Yeah. This is the worst time of year for me because we're going into Halloween, which means a ton of candy. Then we're going into Thanksgiving and Christmas, which means just turkey and stuffing and all that stuff. And for a fat guy, that's bad. Okay. So I want to be good, but it's so good,
Yeah, that's so much better.
I know, right? Okay. All right, so let's see what we got here. Okay. Okay, and now this one. Okay, let's go ahead and take a look. This is if you have values in your expected frequency cells which are less than 5, okay, you can solve that problem easily by just combining a few of your columns, just reworking your observed data. Now, the Yates Continuity correction, this is a modified version of the formula we've been looking at. So the chi-squared test may also be unreliable if the number of degrees of freedom is 1. So if you're starting with a 2 by 2 contingency table, this is definitely going to happen. All right. To improve the reliability of the chi-squared test for a 2x2 contingency table, we apply the Yates continuity correction. So here we go. We take the summation. Now we're still taking the difference of the observed and the expected frequency values, but we take that in absolute value, we subtract 0.5, and we square that difference. And we still go ahead and divide by the expected frequency values. Okay, so let's go ahead, let's work one of these and see if we can get one done before the bell rings. We should be able to. 80 people were surveyed to find whether they enjoyed surfing and skiing. The results are shown alongside. All right, so we have a 2x2 table, so we definitely want to go ahead and use the Yates continuity correction. Test at a 1% level whether there is an association between enjoying surfing and enjoying skiing. Okay, so let's see here. First off, Gabby, you still have that out, right? We're testing it at 1% with a DF of 1. So what's the critical value? There you go. So chi-squared critical. You said 6.63? Okay. 6.63. Okay, 1% with a DF of 1. Okay, now this one we are going to have to go ahead and take a look at by hand because we have the modified formula. And let's see here. I don't believe I have. Didn't think I had a spreadsheet here. So we'll just go ahead and do this. I'll go ahead and make my columns here. Okay, so let's say we have my observed frequency. Now we have my expected frequency. All right, so the observed, let me go ahead and get to this problem. We got 17, 15, 8, 40. 17, 15, 8, 40. Now remember, here's the formula. We want to take the sum of the absolute value difference between the observed and the expected. From that, we want to subtract 0.5, square that quantity, and divide it all by the expected value. Okay. So first off, we need to know what the expected values are. Do we want to go ahead and do this part by hand, or you just want to go ahead and run through on the calculator real quick? On the calculator? Okay. So the expected values are still going to be the same for those. So let me go ahead and plug these guys in and see what we get here. Document B. Okay, so, and also we'll get the opportunity to see how the calculator differs from what we're going to get. So let's see here. We need a 2x2. Okay, so 2x2. All right, where our values are 17, 15, and then I've got 8 and 40. Okay, let's go ahead and save that as X. All right. Now, like we've seen several times today, menu, statistics, tests, two-way test. Okay, for variable X. Okay, so according to this, we're going to get a chi-squared value of 11 point, let's say 88. 11.88. Now, compare that to what Gabby told us was our critical value. Since our value was bigger than this one, what are we saying? Is there a relationship between enjoying surfing and enjoying skiing? Okay, according to this, there's something there. Okay, so now let's see what happens when we go ahead and get the rest of this. So I'm going to get the expected frequency values. Okay. Now remember, I went 17, 15, 8, 40. Okay. So I don't know. It says point. I'm hoping that's 0.0. It is? Okay. So I'm going to go ahead and run with that. So let's say 10, 22, 15, 33. 10, 22, 15, 33. Okay. Okay, so 10, 22, was it 15 and, daggum, I missed it. 33, yeah, I was so close. Okay, now let's say you were going to go ahead and do this by hand. Well, what other columns would you create to make this a little easier on yourself? We definitely want what? Okay, so we want to take the absolute value of those differences. Okay. And then we could go ahead and do 2 more. We could take care of the numerator. Once we have this difference, we could go ahead and take that, subtract the 0.5, and then square it. And then right here, I'm not going to be able to, well, maybe I can fit the whole thing in. Maybe. If not, minus FE minus 0.5 squared. Hey, I was able to get it in. Yay. Okay. So there we go. Okay. All right, so let's see. 17 minus 10, 7. 15 minus 22. Oh. Remember, we want the absolute value. Okay. Then I have 8 minus 15, absolute value 7, and 40 minus 33, 7. Okay, now remember when we started doing these by hand last week, we did notice patterns, right? Okay. So I want to go ahead and first subtract 0.5. So that's going to be the same for all of these. So I'm going to come on over here. I need 7. Oh, I already know that's 6.5. What am I doing? I don't need to type that in. So now 6.5 squared. So I'm getting 42.25. Okay. 42.25. Excuse me. Okay. So did everybody agree with what I've done so far? Okay, not too bad. All right, now these values in this last column, these are going to be different because we're each dividing those by their original expected value. So help me out. 42.25 divided by 10. 4.225. Okay. Now I need 42.25 divided by 22. 1.92. 42.25 divided by 15. 2.82. And 42.25 divided by 33. 1.28. Okay. And now my calculated value will be the sum of that last column right there. So 4.225, 1.92, 2.82, 1.28. What do we got? 10.25. Would you guys agree? Okay. Now, let's go back and compare it. Once I get back over here. Yeah, well, I was already on this. Yeah. Okay. So now, by the formula, we got 10.25. What was it on the calculator? I forget. 11.88. Okay. So calculator 11.88. So in either case, are we okay? Yes. Okay. So this one, it turns out that the original one was reliable. But if you have a 2x2 contingency table, it's a good idea to run through it with this modified formula just to be sure. Okay. And there you go. I mean, that's really all you got to worry about. Like I said, will you be tested or quizzed on this? No. Okay. This is the only time this is going to show up is if, based on the data you collect or from whatever source you go to, you want to go ahead and use the chi-squared test for independence if one of these two items comes up. If any of the expected frequency values are less than 5, or if you have a DF of 1. Yes, ma'am. Oh, no, you don't have to. But, you know, if you go ahead and take a look very quickly at that criteria that I went ahead and gave you, I've got it someplace here. Here it is. You know, how the points are actually awarded. If you go ahead and take a look at Part C, the mathematical processes. Okay, number 1, the student carries out at least 2 simple mathematical processes. At least 2 simple mathematical processes have been carried out correctly. 3 points, at least 2 simple mathematical processes have been carried out correctly. And then there's a little more information that goes with it. But in order to get at least 4 points for that particular section, the simple relevant mathematical processes have been carried out correctly. In addition, at least 1 relevant further process has been carried out. So the way I'm looking at it, I think one of the higher relevant processes would be chi-squared. I would also consider that. I'm sorry?
I'm trying to figure out if
Okay. Like if you could go ahead and create a contingency table. Okay. And I would also consider. I would probably say the top two, which are usually the most useful to people, is going to be this and the correlation coefficient. I would consider that a higher process. But now the lower, what they're referring to as simple mathematical processes, like measures of central tendency, standard deviation, percents. Now it's something that you're still calculating, but nothing that really takes time or is involved. Okay. There you go. So good, good, good. Any other questions? Right. Okay, well, I've got 203, so I'd say let's go ahead and stop there.